Welcome to this comprehensive guide on building an inventory system in Unity 3D, leveraging the power of C# lists and dictionaries for efficient game development. An inventory system is a fundamental component in many games, allowing players to collect, manage, and utilize various items throughout their adventure. This tutorial is specifically designed for beginners in both Unity and C# development, providing a clear, step-by-step approach to mastering this essential game mechanic. We'll begin by setting up our Unity project, then dive into C# scripting to build the core logic using lists and dictionaries, and finally integrate it all within the Unity engine. The inventory system is crucial for player progression and interaction, enabling features like crafting, trading, and equipment management. We will cover the entire process, from initial project setup to demonstrating the fully functional inventory system within Unity. Let's start by creating a new Unity project. Open Unity Hub and select New Project, choosing the 3D Core template for our game. Give your project a meaningful name, like Inventory System Tutorial, and choose a suitable location on your computer. Once the project loads, we'll set up a basic scene. This involves creating a simple environment and a placeholder for our player character. Good project organization is vital. Create a clear folder structure in your project window for scripts, prefabs, and other assets. This practice keeps your project tidy and makes it easier to locate specific files as your game grows in complexity. Familiarize yourself with the Unity interface, the scene view for editing, game view for testing, hierarchy for objects, and inspector for component properties. C# is the primary scripting language for Unity, enabling us to define game logic, interactions, and system behaviors. To begin scripting, right-click in your Scripts folder in Unity, select Create, then C# script, and name it Player Controller. Double-click the script to open it in Visual Studio. Here, we'll write our C# code. Variables store data. Data types define the kind of data a variable can hold, and functions are blocks of code that perform specific tasks. We can use debug, log to print messages to the Unity console, which is incredibly useful for debugging and understanding our code's execution. The start function executes once when the script is enabled, while update runs every frame, making them essential for game loop management. Lists in C# are dynamic arrays that can grow or shrink in size, making them perfect for managing collections of items where the number of elements might change. Unlike fixed-size arrays, lists offer flexibility with methods like add, remove, count, and clear to manipulate their contents efficiently. To declare a list, specify the type of elements it will hold. For example, list string for item names. Adding items is straightforward with the add method. For instance, player items, add, will place a new item into our inventory. Removing items can be done using remove, which takes the item itself, or remove at if you know the item's index. The count property tells us how many items are currently in the list, useful for displaying inventory size. We can easily iterate through a list using a for each loop, allowing us to process each item, such as displaying inventory contents. Lists are ideal for storing inventory items like item names or IDs, providing a dynamic and ordered collection. This dynamic nature makes lists incredibly versatile for inventories where items are constantly being added or removed. Dictionaries, on the other hand, store data as key-value pairs, offering incredibly fast retrieval of information based on a unique key. Each key must be unique, allowing us to quickly look up a value, such as an item's description or icon, using its corresponding key. To declare a dictionary, you specify both the key type and the value type. For example, dictionary, string, int for item names and their quantities. Adding entries to a dictionary is similar to lists, using the add method with both a key and a value, item quantities, add. Retrieving a value is done by providing the key in square brackets, like in gold amount equals item quantities, gold. The contains key method is crucial for checking if a key already exists before attempting to access or add it, preventing errors. For safer retrieval, try getValue attempts to get a value and returns a Boolean indicating success, without throwing an error if the key is absent. Dictionaries are invaluable for storing detailed item data, such as descriptions, icons, or stats, where each item has a unique identifier. This allows for quick lookups of item properties based on their name or ID, which is much faster than searching through a list. Now, let's combine our knowledge of lists and dictionaries to build the Inventory Manager script, the heart of our inventory system. This script will handle adding items, removing items, and checking for an item's presence within the player's inventory. First, define a simple item data class to hold properties like name, description, and whether it's stackable. In Inventory Manager, declare a list inventory slot, where inventory slot is another custom class holding an item data and its quantity. Also, create a dictionary, string, item data to store all possible item data, which will populate at the start. The add item function will check if the item is stackable and if an existing slot can accommodate it. If it's stackable and a slot is found, we increment the quantity. Otherwise, a new inventory slot is created. The remove item function will decrement the quantity of an item or remove the slot entirely if the quantity drops to 0. We'll also implement a hasItem function to quickly check if a player possesses a specific item. By using both data structures, we can efficiently store the player's current items in a list and quickly retrieve detailed information about each item from a dictionary. With our Inventory Manager script ready, let's create the visual interface for our inventory system in Unity. Create a new UI canvas by right-clicking in the hierarchy, selecting UI, then Canvas. Set its render mode to Screen Space, Camera. Inside the canvas, add a UI panel to serve as the background for your inventory. Adjust its size and position to your liking. Next, create multiple UI images to act as individual item slots within your inventory panel. Attach a new script, perhaps named Inventory UI, to your canvas. This script will manage the visual updates. Link the UI elements to the Inventory UI script by creating public variables for your item slots and assigning them in the inspector. Demonstrating the system, we'll show how to add and remove items directly through the UI, providing a tangible interaction. Clear and concise code is paramount for collaboration and future updates. Always strive for readability and maintainability. Use meaningful variable names and consistent formatting to make your code easy for others and your future self to understand. Utilize the Unity documentation and online resources like forums and communities. They are invaluable tools for problem solving and continuous learning. Don't be afraid to experiment and break things. It's often the best way to learn and discover new solutions. We've covered setting up your project, understanding C# basics, and implementing a functional inventory system using lists and dictionaries. Continue experimenting with Unity and C#, building upon this foundation to create even more complex and engaging game mechanics. Thank you for joining this tutorial. We hope it empowers you to create amazing things in your game development journey.